Hey everybody, it's Mr. Cropper. I'm back again to do another little quick tutorial video. This time we're talking about the real number system. And so what we're going to do is we're going to break it down into its two classes and then break it down a little bit more just to refresh you on what the real number system is. So let's start at the top of the chain and let's start with real numbers because all numbers are real, right? All of them. So think of a number in your head right now. I'll wait. All right, got it? All right, it's real. All right, moving on. So anyway, what we're going to do is we're going to break it down into rational and irrational. So this goes back to that Arnold stuff that we talked about a long time ago at the beginning of the school year. And rational, the easiest way we can describe a rational number is it makes sense to us. We can understand it. We can imagine it. We can picture it in our mind, if possibly. All right. So if I'm talking to you and I say, "Hey, I need 50 cents," you know what 50 cents is. It makes sense to you. Even if I give you a repeating number like 0.333333, and I say it repeats forever, and I say, "Hey, what's the 50,000th digit?" Well, you know it's a 3. Your brain understands that. So this rational number goes off into two categories. We have integers, so I didn't write that first. We have non-integers. And over here we got our integers. So now, integers break in the whole, and the whole breaks into our naturals. So if you have a decimal, you cannot exist on this side right here, on this little box right here. It cannot be a decimal over here. But if you do have a decimal, well, let's start looking here. You got some decimals. So first off, let's talk about fractions. Remember, fractionals are rational. Fractional is rational. And I can hashtag that here. Boom. Boom. There. Hashtag. Boom. Fractional is rational. Alright? And we also have decimals here that stop at terminating decimals or repeats. Alright? So you got stop or repeating decimals. Terminating decimals with the repeating decimals. I'm here to start and they need to stop at between. So like 0.5 or 0.125. Like even a negative 4.63. It just stops. And that makes sense because what comes next? Nothing. Alright, so over here is our rational side. These things make sense to us. But over here, in the recesses of the real number system, well, that's where we got the irrational numbers. And these don't make sense. Because we can't predict what's coming next. We have no idea. It can be anything. Alright? Pi is irrational. So don't talk to pi because it'll go on forever. And it never repeats itself. So pi is our most famous irrational number. Alright? So also, non-perfect squares. So for example, if I had you square root 54, and I just happen to have a calculator here, and if I square root 54, second x squared on the 30x TIs, I get 7.348469228. What comes next? I don't know! Nobody knows. Well, maybe somebody who has a better calculator than this would know, but we can't make a prediction what comes next. It doesn't make sense to us. We need our numbers to make sense. All right? Now, speaking of non-perfect squares, we need to find where they live. We can't really pinpoint it exactly, but we can get a pretty good idea. And the way we do that is by finding where does it live, as close as possible. So let's go back to that square root of 54 that we just had a second ago. And when I type that in on the calculator, once again, I'm looking at 7.348 blah, blah, blah. Well, I can't pinpoint exactly his exact address. But if I look at a number line, and let's start at 5 here. 6, here's 7, here's 8, here's 9, and here's 10. And I'm looking here and I say, okay, where roughly does he live? If he lives at 7.34 blah, 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 well, he's living in somewhere there. He's not halfway, because that means it would be 7.5 something. And this is about 7.34. And I put that dot, 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 meaning it's going on forever and never repeating. So we can get close, but we can never actually get the true home for him. All right? So let's say I had the square root of, let's go with, I'll use something from this, 87. Well, let's find the perfect squares that are around it. The perfect square that's above 87 is 100. The perfect square below 87 is 81. I know those square roots. Well, that's 10, and that's 9. So the square root of 87, if I don't have a calculator, well, I know it has to live somewhere between 9 and 10. Well, 87 is a little bit closer to 81 than it is 100, but it's also pretty close to in between it. So when I approximate where that bad boy lives, I know it's going to be between 9 and 10, almost in the middle there. So if I grab my calculator, it's the second x squared, and I do 87, it comes out as 9.327. A little bit, maybe a little bit more that way, but pretty close, right? So we're trying to figure out approximately what two numbers would it between. You can do the calculator way and type it in and find the square root and go from there, or you can look at the perfect squares that are above it and below it and say, okay, it's got to live between those two. All right? So apparently in the last video, I just started drawing random things, so here it is. Sorry, I don't want to draw an ink out. There's a cow. And it's happy. He's happy. He's a happy cow. Alright? So, oh, he's good. I don't know why you'd be happy if you're a hopeless cow. But, there we go. So it's on the cow. Tail. Tail's very important. And there's a cow. So, and he says, because my cows can speak. Alright, have a good one. Stay safe out there. See ya.